All right, guys. Hey, it's Ms. Hodges here. I'm here to show you how to draw force diagrams. This is just meant to be a supplement. Please do not use this as just the answer key so that you can get credit for doing the work. It's meant to help you. And so if you haven't done the worksheet already, I encourage you to stop the video right now, work the worksheet out, and then use this video to help explain any concepts that you might not understand. Again, I don't work out the answers to the test. So if you don't know how to do this, it's only to your disadvantage. So please make sure you at least attempt to do it before you watch this video. All right, so let's go ahead and get started. We're gonna work out all 5 problems. I'm going to try to do it quickly as I can so that, you're not watching 30-minute videos on how to do a worksheet. So number 1 says a book is at rest on a tabletop. A force diagram for the situation looks like this. All right, so what is a force diagram? Basically, it's just a diagram that shows me all of the forces that are acting on any object. And so if I have a book on, if I have a book, excuse me, my Apple Pencil's not working. Interesting. I'm gonna back up there. I think I need to charge it here for a second. I'm gonna pause. All right, guys, check this out. I was spending the last 10 minutes trying to figure out why my Apple Pencil wasn't working. It's because I had the white color for the ink. So whatever. In any case, I fixed the problem. Let's get started. So a book is at rest on a tabletop. A force diagram of this situation looks like this. So I'm gonna draw a book on a tabletop. Here we go. Here's my table. Not the most beautiful table. Okay, here's some legs. There we go. Little leg here, little leg there. And what forces would be acting on this this box? Well, obviously there is a force that keeps the box from floating away. Right? What force keeps the box from floating away? It's acting in the downward direction, and this is my force. My force due to gravity. This force is keeping my book on the table, and so it's not floating out into space. But there's also a force that keeps my book from falling through the table, onto the floor, through the ground, all the way to the other side of the earth, or center of the earth, because theoretically that's where it would stop. But that force is the force applied by the table in the upward direction, opposing gravity, and that is my normal force. Okay, the book is at rest, so there's no forces applied to it. Nobody's pushing the book. It's not moving anywhere, so frictional force isn't acting on the book. So those are our only forces. So now number 2, we have a tree is free falling. A tree is free falling. An egg is free falling from a nest in a tree. Here's our tree. Our tree right here. And we have an egg falling from the tree. Okay. We're going to neglect air resistance. We're going to draw a force diagram. Okay, so our egg is free falling, which means it's being it's moving in the downward direction. And what force is making it move in the downward direction? Obviously, the force of gravity. And the force due to gravity is making our egg fall down. And because we're neglecting air resistance, that means there's not an opposing force. And so nobody's applying a force. It's not like somebody threw the egg down, and nobody's pushing to the left or right on the egg. So that's the only force acting on the egg, is the force due to gravity. All right, so a girl is suspended motionless from a bar which hangs from the ceiling by 2 ropes. Okay, so we have, here's 2 ropes. Here's a bar. And we have a little person here, hanging on to dear life. A force diagram for the little girl would look like what? Well, again, she's hanging from the ropes. Right? Why is she not floating away? Because something is pulling her down. And whatever is pulling her down, the thing that's pulling her down is the force due to gravity. but there's also a force that's supporting her. It's a force that's supporting her so that she's not falling off of the bar onto the ground. What's keeping her from falling onto the ground? Well, obviously, it's the force that's holding her up, and it's going in the upward direction caused by the bar, and it's the normal force. It's the force opposing the force of gravity, holding her up, keeping her from falling. That supportive force. All right, so number 4, a flying squirrel is gliding, right? No wing flaps, meaning no air resistance, is gliding from tree to tree at a constant velocity. Consider air resistance. A force diagram of this situation looks like this. Well, this one's a little bit more tricky, right? So we have a squirrel, and I don't really know how to draw a flying squirrel. Look at that, like that. Now, here we go. Yeah, we got a little tail here. Sure, that's our flying squirrel, and he's happy to be flying. Good squirrel. And he's flying from tree to tree at a constant velocity. Okay, constant velocity. Consider air resistance. A force diagram for this situation looks like this. All right, so what does a constant velocity mean? Constant velocity means that he's not slowing down, he's not speeding up, he's flying with a constant speed. And if he's not speeding down or slowing up, that means he has no acceleration. He's not speeding up or slowing down, no acceleration. Which means there isn't a net force applying this way or that way. There is no net force, right? There is no force that's acting more strongly in one direction than the other. And so if he is in the air, any object in the air is, all objects on Earth are subject to the force of gravity. But he also has an opposing force in the opposite direction. But he's not being supported by anything. The reason why he can float in the air is because of the force of air resistance, which is opposing that force of gravity. And because these two forces are equal, these two forces here, they are equal to each other, allows this squirrel to fly at a constant velocity. So the force of air resistance keeps the squirrel from falling down, and the force of gravity keeps the squirrel from flying away into space. So lastly, a rightward force is applied to a book in order to move it across a desk. With a rightward acceleration, consider frictional forces, neglect air forces. The force diagram for this situation looks like this. So a couple of things that I'm going to underline. The rightward force is applied to move it across rightward with a rightward acceleration. We're going to consider frictional forces. We're going to neglect air resistance. We're going to look at a force diagram. And here's my book. And it's on a table. So someone is applying a rightward force to the book. And it's applied, so it's an applied force. And we know that there is a rightward acceleration, which means that my force is accelerating or getting faster. Okay, so there's obviously another force on my book. It's on a table. This little interaction between the book and the table is going to cause friction. Okay, it's what's going to keep my book from just sliding into forever, and that force is going to oppose the frictional force. So here's my it's going to oppose the applied force. So friction opposes applied force. Frictional force opposes applied force. But what does it tell me? This is really important, you guys. this rightward acceleration lets me know that the force in the rightward direction is larger than the force in the left direction, than the force that is opposing it. So I'm going to draw my arrow much bigger. Okay, and I'm going to erase this one, make it a little bit smaller so that you really can see that the force of friction is smaller than the applied force because we have this rightward acceleration. Okay, and so hopefully that makes a little more sense. The reason why we have a rightward acceleration is because the force in the rightward direction is greater than the force that opposes it in the leftward direction, that frictional force. All right, so I think we've answered the questions here in record time, 10 minutes, 11 minutes. So hopefully this provides you enough information to help you answer these questions. If you have any questions, please go talk to your physics teacher, or you can hit me up in my email. I'll be happy to answer any specific questions that you have. Thanks for listening. Hopefully it helps you out, and so will the future videos. All right, guys, have a good one.